Let's take a look at half-angle identities. So we have two of them that we're going to work with today. The first is sine of x over 2, and that's why we call it a half-angle identity, because our input here is half of an angle. And sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Notice on the right-hand side of the identity, our input is just the angle x, whereas on the left-hand side, we have half of that angle, x over 2. And our second identity says cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine x over 2. Now, this plus or minus in front, we have to decide whether to use the positive or the negative sign. And it's all going to depend on the location of our angle x over 2. So this plus or minus here, we choose positive or negative depending on the location of x over 2. So let's look at an example. So let's use a half-angle identity to find the exact value of cosine of 22.5 degrees. Okay, since we're finding the exact value of cosine of 22.5 degrees, we want to use this second identity, cosine of x over 2. So cosine of 22.5 degrees, and notice here our half angle x over 2 is equal to 22.5 degrees. So that's x over 2. So now on the right-hand side of our identity, we need to figure out what x is, which we can do. If I take this equation and just solve for x, so I need to multiply both sides by 2, what we would get is x is equal to 45 degrees. And now we can plug into the right-hand side of our identity. Oh, and let's decide, are we going to use the plus sign or the minus sign? And, well, since 22.5 degrees is in the first quadrant, well, both sine and cosine are positive in the first quadrant, so that lets us know that we're going to choose the positive sign. So we'll get positive the square root of 1 plus cosine of x, remember x here is 45 degrees, and then divided by 2. And now we just need to simplify this. So we'll get the square root, if I don't put the plus in front, it's just understood to be a positive. We'll get the square root of 1 plus cosine of 45 degrees, that's root 2 over 2. And this is divided by 2. But let's simplify this as much as we can. One thing is I can combine my terms in the numerator. So this 1 here, that's like a 2 over 2. So when we add our fractions in the numerator, we'll get 2 plus the square root of 2 over 2. And then this here is divided by, that's divided by 2, right? That's this 2 in the denominator. But now when we go to simplify further, basically this 2 is just going to get absorbed into the denominator. Because if we think about it, 2 plus root 2 over 2, and then this whole thing divided by 2, well, that's the same as taking 2 plus root 2 over 2. And dividing by 2, that's really just the same as multiplying by 1/2. And so when we multiply, we'll get 2 plus root 2, and then our denominator becomes 4. So that's what we have inside of the radical here. 2 plus square root of 2 divided by 4. And then to finish simplifying, well, if I take the square root in the numerator, that'll give us square root of 2 plus radical 2. And then in the denominator, square root of 4 just gives us 2. And this would be our simplified answer. All right, let's take a look at another example. Example 2. Suppose alpha is in quadrant 2, and this means that alpha is between 90 degrees and 180 degrees. If I were to draw a picture of this, right, here's 90 degrees, here's 180 degrees, and of course this is quadrant 2, and so we're just saying alpha is somewhere within this quadrant. And part A asks us, well, what quadrant is alpha over 2 in? And so in order to figure this out, I'm going to work with this inequality here. The fact that alpha is between 90 degrees and 180 degrees, well, I can take this inequality and I can solve for alpha over 2. Basically, I need to divide by 2, and that means all parts of my inequality are going to be divided by 2. And when we simplify, we'll get, 90 degrees over 2 is 45 degrees. That's less than alpha over 2, which is less than 180 over 2 is 90 degrees. And so now if I were to draw a picture, we're saying that alpha over 2 is between 45 degrees and 90 degrees. So alpha over 2 is in here. That means that alpha over 2 is in the first quadrant. So quadrant 1. And now we're going to use this to help us with part B, which says to use a half-angle identity to find the exact value of sine of alpha over 2. And what we're given is that cosine of alpha is equal to -5/8. All right, so since we're trying to find the exact value of sine of alpha over 2, let's start by just using this identity. So what does that identity say again? Sine of alpha over 2 is plus or minus the square root of 1 minus cosine x divided by 2. All right, and now let's start plugging in what we know. So sine of alpha over 2. Oh, and at this point, we have to decide, are we going to use the plus or the minus sign? And again, because our half angle, alpha over 2, is in the first quadrant, we know that sine should be positive. So again, we're going to use the positive sign. And what we'll get is the square root of 1 minus cosine of x. Oh, and sorry, over here I said cosine of x, but really our input here, our angle is alpha, so that should be cosine of alpha. And we were given cosine of alpha. Cosine of alpha is -5/8. So that means for this entire expression, cosine alpha, I'm going to replace that with -5/8. And of course, this is divided by 2. And now we just have to finish simplifying. We'll get the square root of 1. This turns into a plus 5/8 divided by 2. Let's combine our terms in the numerator. I'm going to write this 1 as an 8 over 8. So I can add my fractions. In the numerator, I'll get 13 over 8. And this is divided by 2, which turns into the square root of 13 over 16. Again, that 2 just gets absorbed into the denominator. And now when I finish simplifying, in the numerator we'll have square root of 13, and in the denominator we'll have square root of 16, which is 4. And there we go. This is our exact value of cosine of alpha, or rather sine of alpha over 2.